Hey, so this is Luis Tercero from Trobots Team 5013, and this is how I made my own Limelight object detection model. So the first step was to take a bunch of pictures. Originally, I started with around 200 pictures, and eventually I got up to around 400. And I just took them with my phone, nothing special. We don't need high quality images. I uploaded them all to a Google Drive folder, and I versioned them so that we wouldn't double upload them to the model. Something to consider while you take pictures is to only take pictures from the perspective of your robot. So as you can see, we had a lower robot this year, so all of our pictures are from a low POV. And we tried to get every possible angle, so like 360 degrees around it. Another thing to consider would be possible confounding objects present on the field. For example, our first iteration of the model showed a lot of false negatives with red tape. So what we did was we made another iteration of the model, and we included a lot of pictures with red tape so that it wouldn't mistakenly detect the red tape as a note. After you upload all of the images from your phone to the Google Drive, you have to download them to your computer by clicking here, the three dots, and then download. Okay, so once it's done downloading, it should pop up in your downloads as a zipped file. So all you have to do is right-click that and extract it. And once it's done extracting, you're ready to move on to the next step. So the next step is you should navigate to this website, app.roboflow.com, or you can just look up Roboflow. You can make an account, it's free, and then create a new workspace. The name of the workspace doesn't really matter. And then you're going to want to click on Create New Project. So name your project something descriptive for the data set that you're uploading. I'm going to call mine bumper notes because notes are the objects we're detecting. And here in the annotation group, you're going to want to name what you're detecting. So this year it's called a note. Hit Create Public Project and hit Sync Annotations. Now that you're here, you're going to want to hit Select Folder, and it is going to prompt you. So all you have to do is select the folder of the images that you just downloaded from the Google Drive. Hit Upload. Okay, now that it's done uploading, you can just hit Save and Continue. Now that you're here, you're just going to want to assign the images to yourself. And now for the really, really fun part, you get to start annotating. So just click on Start Annotating. And what you're going to need to do is basically just draw boundaries around the objects you're trying to detect. And try to make them as precise as possible. And once you're done with an image, you can just hit the next key or the right arrow key. And you just do this for all of your images. So I'll time lapse. Okay, and once you're done annotating, it should look like this, and you can just click Add 65 images to Dataset. And generally for a normal machine learning model, this would be a good setup of the percentages. But for our purposes, we only need around 10% to test, since we will be testing it actively on the Limelight. Okay, and now that you're here, if this is your first data set, all you have to do is create new version, and it'll take you here. But if you have already other data sets that you would like to combine with this new data set, what you would do is you would click on the three dots for your new project and hit Merge. Now select the other two data sets that you would like to combine with the new data set. Hit Merge Projects up here, and then name it. I'm going to name it OGRTB Notes. And then click on Merge Projects. Okay, and now you can go here And as you can see, it should take you to the same exact place that we would have been if this is your first dataset. If it doesn't take you there, you can click here on Generate in the left side panel, and this is where you'll end up. And from here, basically what you have to choose are some pre-processing and augmentation steps. And this is basically going to increase the size of your data set by slightly altering the images, which is going to make your model more effective. So here are the settings that I've found have worked for this this year. And so what I'm going to do is I'm just going to add these steps to our new data set, and I'll time lapse through that. Okay, and the point of this is pretty much so that you can have other images that are similar to the images that you took. So you don't want to choose something drastically different. Like you don't want to change the exposure to 99% because that's going to create images that are just not going to be useful. So you want to keep the changes to be mildly different so that your model can detect different situations, but also similar enough that they will not be like random images that will not be useful. And for the image size, you pretty much always want to make the biggest model possible. Obviously, I'm not paying for this, so 3x is the biggest size. But if your computer is slow, then you might want to consider only making it 2x because that way you will train the model faster. And then you just hit create. And it is just going to load. And once it's done loading, it's going to look a lot like this. You're going to want to click on Export Dataset. Make sure it's on Pascal VOC. Click on Show Download Code and then continue. It's going to take a while for you. And then you're going to want to copy this, or you can just hit the copy button here. And you are going to use this in a future step. So store it in like a notepad or something. So the next thing you want to do is open the Google Colab file that is linked on the screen. A Google Colab file is pretty much a web hosting service for scripts, so it's going to run your script in the background without using all of your crappy school computer's resources. And shout out to Spectrum 3847 because they wrote the original script, which I adapted, and the script that you're seeing is the adapted version. So the first thing you're going to want to do is click on this arrow right here by the reconnect button, and you're going to want to click on change runtime type and click on CPU because neither of these really add anything, the T4 GPU or the TPU, and they have a much shorter maximum allowed time. The CPU maximum time is 12 hours, which should be enough for most training models. And then you're going to want to click reconnect. And after you connect, you're going to want to scroll down past a couple cells to the cell that shows this Roboflow data. And you might recognize this from earlier. This is pretty much the same thing that you copied from Roboflow. So what you're going to want to do is select it all and then paste your own codes. And after that's done, just scroll down to the next script. So if you look at the script, there are some uppercase strings, and those are strings that you're going to have to replace. So let me just select all of the project names. And your project name is going to be exactly what comes before image dataset right here. So for me, it's OG RTB notes. Except instead of spaces, there are hyphens. Now your object name is going to be the annotation group from earlier. For this here, it is just note. And something else that you can customize here is epochs. So epochs is how many times that batch is going to get ran, pretty much. So I recommend between 15 and 20. If your data set size is larger, you should trend towards smaller epochs. If you have a smaller data set, go for larger epochs. And I forgot to mention, you do have to change the file name, and I called mine Note Detector. And after that is done, you are ready to run the whole program. So you can scroll all the way up. You can just click on Runtime and then hit Run All. And after an hour to 6 hours roughly, it is going to be trained completely. Everything is going to be ran. And in your files, there is going to be two files. One of them is going to be called Note Detector.tflight. And the other one is going to be called Note Detector _ Edge TPU. And the Edge TPU file is specifically optimized for Limelights. So you would just upload that file to the Limelight. And something important to keep in mind about Google Colab is that if you idle at your computer, so if it doesn't sense any actions for longer than about 20 to 30 minutes, it is going to stop processing. So an important step for this would be to create a simple program that's just going to click your computer once every minute or so. And that way you're going to be able to bypass all of the timeout restrictions. Okay, and if you followed the steps, you should be completely done with the model. You can just upload it straight to the Limelight. However, there are certain occasions where either you have a more powerful computer at hand or the dataset is just too big to be trained in under 12 hours. In which case, you're going to have to connect to something called a local runtime, which is basically going to run the Google Colab on your computer. And so to do this, you have to click this arrow again and click connect to a local runtime. And this is going to look kind of crazy, but all you're going to have to do is look up Colab local runtime, click on the first link, and scroll down here. You are going to have to install Docker, which is an app that basically allows you to run the Colab on your computer without like bricking your computer. You're going to want to download whichever computer you have. And once it's completely installed, you're going to want to go to your terminal. You're going to want to copy this and just paste it into your terminal. And once you run this from your terminal, it's going to take a while. It's going to download a bunch of stuff. But eventually, it is going to return a link. And that link is going to look a lot like this. So you're going to want to replace this link with the one from your terminal. And then you're going to want to click connect. And afterwards, this is going to show connected to a local runtime. And then from the runtime, you can just hit run all. And the exact same thing is going to happen as if you were just running it from the cloud, except you're going to have to access the files from Docker. And that's a pretty simple process. So I believe in you. And so once the script finishes running, you're going to want to download the .tflight and the edge TPU.tflight files. And obviously, those are going to be named whatever you name them in the script. And all that's left is to upload these to your Limelights. So you're going to want to connect to your Limelight. And you're going to want to open up a pipeline that is not currently being used. And then you're going to set up the settings how I do. So the pipeline type needs to be detector. The LEDs need to be off. The orientation needs to be upside down. And the exposure is turned to the max. Next, you go to config. And you're going to want to upload the TFLite model file right here. And you have to make sure that it's the Edge TPU file because that is specifically optimized for the Limelight. But you also need to upload a labels file. And so all you got to do is create a new text file. Name it whatever you want. And in it, all you have to do is type the name of the annotations that you put in your Roboflow and in the script. So it's just note for me. Save it, close out of it. Then we go back to the Limelight and just upload that file to your Limelight. But our model is still not detecting the object. And that's because the confidence threshold is set too high. The confidence threshold is kind of like a balance between false positives and false negatives. So if your confidence threshold is too high, it's not going to detect the object when it needs to. Then as you lower it, it's going to start detecting the object. But if you lower it too far, it's going to start detecting extra objects that aren't there. So you want to find a nice balance, and for this model, it's around 0.4. And as you can see, even if the robot spins, it's still detecting the note properly. And so that's all you need to do to create and upload your custom object detection model to your Limelight. Thank you for watching.